your destiny. Good morning, students. Good morning to your destiny. Now, like I've been showing you about the drawing. So this is the cam. This is the cam assembly, and this is the cam shaft, and this is the gear. This cam is driven by the engine like this. So as it is moving, you can see the follower here from this place. You can see the follower is also moving. So when you are told to draw the cam profile, you're simply going to draw how the cam is rotating the follower like this, because the follower has to be on this part. So when it is like this, the follower is lifted up. When it is like this, the follower is on dwell. When it is like this, the follower is still on dwell. When it is like this, the follower now has a return stroke. So we have the out stroke on the right, we have the dwell, then we have the return stroke, then we have the dwell, and then we have the out stroke. Please subscribe to my YouTube channel and I will show you more about this. Yes, good morning, students. Good morning, good morning, good morning. I hope God has blessed you, and I pray that Jesus Christ of Nazareth has showered you with his blessings. We thank God for the gift of life. We give back all the glory unto his name. His name is Shekinah. He's the God who lives, the God of Israel, who has given us another chance this day that we may learn something. Now, I've also brought you another knec past paper question, which is a 22 past paper question. Like I told you in the beginning of this course, or in the beginning of this module, if you have not watched that video, please subscribe to my YouTube channel at official Mark Mungai, and like and also comment and watch this video. I told you that we are starting a new topic, and this is on cam. And since we started this course, we were able to establish that in every past paper, this cam question will always be there. Like now in this past paper question, this 22 past, this for automotive engineering, we have the question on cams, which is number 2. And how many marks is it? It is 20 marks. We were able to establish also that the question on gears, you can see down here, there is also another question on gears, which is also 20 marks. And we said, if we are able now to do cams and do about gears, then we will be able to get 40 marks and pass this exam before doing any other question in this part, because we have 5 questions in this paper. Another past paper question, which is now for welding and fabrication and production option. We also saw that there is the assembly drawings, there is all these questions, but there is also a question on cams. And we saw that the question on cams, it is 20 marks. And we saw that in these questions, knec demands that we draw a displacement diagram or a cam profile of a combine of the simple harmonic, of the uniform acceleration and retardation motion, and uniform velocity motion. So my entire course, I have taught you single-handedly, I have taught you cam displacement first separately under simple harmonic motion, cam displacement diagram and cam profile under uniform retardation and acceleration motion, cam displacement diagram and cam profile under uniform velocity. If you have not watched those videos, please watch all those videos. You will see where I've taught you everything. There is another also past paper question, and this is a knec past paper question. Again, a 2022 past paper question. You can see there is the first question that is on assembly drawings, but there is another question here. This question, section B, the question on cams, question number 3. You see, knec past paper question, cam is a common question. That's why I told you these tutorials and this particular channel, this particular YouTube channel, it is to help you. It is a guide. It is something that is to help you as you are researching, so that you can find the correct information and know how to answer questions, and even know what to anticipate in knec questions. Now, in this past paper question, you can see the examiner demands that we draw a cam profile with all of them combined, with simple harmonic motion, with uniform retardation, uniform velocity, and uniform acceleration and retardation motion. And you cannot draw the combine if you don't know how to draw simple harmonic first separately. You cannot draw a combine of the three if you do not know how to draw the uniform velocity curve, displacement and curve profile separately. You cannot know how to draw uniform acceleration and retardation if you have not learned, if you cannot draw the combine, if you don't know how to draw the uniform acceleration and retardation separately. But in this past paper question, it will help you in your revision. It will help you to understand. Next questions are almost the same. They all twist. They only twist figures or twist something. So if you have seen an example and know and understood everything else and put God in front, you will be able to do this. This is the final question that I want to do under this topic. Please subscribe to my YouTube channel and I will show you. And so, this is the question. It is the question from this past paper from 2022. Students, they did this question and I will do it now. The question asked is a knec 2022. Using the following data, design a radial cam. So, design a radial cam. So, I told you there are two types of cams. There is a cylindrical cam and a radial cam. So, we are supposed to design a radial cam with the following specifications. We are told that from 0 to 100 degrees, it is simple harmonic motion rise. So there is an outstroke with simple harmonic rise. Number 2, we are told from 100 to 150 degrees, it is dwell. That is 50 degrees. Then you are told from 150 to 220 degrees, we are told there is uniform velocity fall of 20 millimeters. There is another stroke of 20 millimeters. That is 70 degrees. And you are told from 220 degrees to 270 degrees, there is a dwell. Then there is 270 degrees to 360 degrees. There is uniform acceleration and retardation fall of 40 millimeters. The cam specification. The shaft diameter should be 14 millimeters. The roller follower should be 14 millimeters. The base circle diameter should be 140 millimeters and the direction of rotation should be clockwise. Construction, I've written to you. And what have we been given? Solution, we have been given the roller diameter is 14 millimeters. Base circle radius will be 20 millimeters. And the prime circle now, because when it comes to roller, here we are drawing using a follower we are using a follower or roller follower. Whenever you see, like in this question, you have not been told to use any roller follower. There is no something like that. But we see that, you have been told there is a roller follower. If you know there is a roller follower, then you know very well there must be a prime circle. Please subscribe to my YouTube channel. Watch my previous videos. I have shown you how to draw a cam profile using a roller. It is much different. There is an additional requirement for you. You must look for prime circle, and there is a formula to this. You say base circle radius, not diameter. Base circle. Realize in our question we have been given base circle diameter, but in our formula it requires us to do base circle radius plus a half of the roller diameter. The roller diameter we have been told is 14, so it will be 14 divided by 2, which is 7, plus 20, which is the radius of the base circle. It will be 27 millimeters or 27 centimeters. Now I want to take you quickly on how to construct. The very first thing I've told you, and I've always told you, is that when now you're drawing a combine, you have to be keen, be very careful, because I want to show you something. Be very careful. So you draw your scale. I have told you, you always have your scale, that 360 degrees is equals to 18 centimeters. This one you must put it in your back of your mind so that you may be able now to draw this. So after you've been able to establish that, you now begin. We are told that you go back to your question now. Under the simple harmonic motion or the rise, we are told that we have it is from 0 to 100. 0 to 100. So we have 100 rise. 100 rise, but we are given a different stroke. You see, under simple harmonic, you'll be given a stroke of 60 millimeters. Under uniform and velocity fall, you're being given a stroke of 20 millimeters. Under uniform acceleration tradition, you're being given a fall of 40 millimeters. So a stroke of 40 millimeters. So be very careful. Here you use wisdom, and so follow very keenly, and I will show you how to draw the cam displacement diagram of a combine. So the very first thing we will start first with the simple harmonic. So the simple harmonic, we will start with the simple harmonic. So here You again draw what is the stroke given to us. It is 60. So first draw 60 like that. Then draw your 18 like this, the 18 centimeters there. The cam angular displacement, you change it into centimeters, it should be 18. So from this particular point like this, you draw it like that. So you just draw it on the bottom. Don't draw it on the top. First draw it on the bottom. So you come and say, you've been told that it is simple harmonic first, from 0 to 100. So we want to convert 100 degrees. From 100 divided by minus 0, it is 100. 100 into centimeters, where we say 360 degrees is equals to 18 centimeters. What about 100? So it will be 100 times 18. That is 1800 divided by 360. It will be 5 centimeters. So it is the simple harmonic motion will go for 5 centimeters. So from the bottom here, measure 5 centimeters. Then you make a mark like this. Make a very nice mark like that. So again, stand here on top here again using the same specifications. Again, draw 5 centimeters properly. So from here to here, that is 5 centimeters. So this is simple harmonic. So from this particular point again like this, now you must again straight. Sorry, there is an error. I will correct it. Let me first draw this line like this. So it should be like that. There is a small error here. No, God will bless us with a good studio, but at first we want to begin from where we are, so that students can be able to understand the basic. The most important thing is to understand first the basics first. Understand the basics first, then the rest will come. As the Bible says, seek ye first the kingdom of God, and all these things shall come to you. You first seek God, and God will give you this knowledge. So here, this one is our simple harmonic, and as we know very well, simple harmonic, under simple harmonic, we take the stroke diameter and divide it into 2 to give us a radius. So our stroke here, it was 6 centimeters. So we divide it by 2, it will be 3 centimeters. Then after you found 3 centimeters like that, again standing on this particular point here, you can maybe adjust slowly like that, so as to get the correct measurements like this. Yes, that. Now draw now like that. Then the very next thing that we do, we have to divide this semicircle into 6 equal parts. We must divide this semicircle into 6 equal parts. So from here again, so now with the same 3 centimeters diameter, radius like this, we strike an arc here. Stand on the next part, like which is here, strike an arc. Stand on this part here, strike an arc here. Stand on the other part like this, strike an arc like that. So from this particular point, again join your work like this. Join your work like this. Again from here, again join your work like this. Join your work like this. Again from this particular point and junction, again join your work. Then name your work. This is 0, 1, 2, 3, 4, 5, 6. So you'll be able to divide this into 6 equal parts. The next thing that we do, we divide this outstroke into 6 equal parts. So you already know that it is 5 centimeters. So we divide 5 into 6. So you take your calculator and say 5 centimeters divided by 6. What will it be? It will be 0.833. So you will divide everywhere by 0.8, 0.8, 0.8. So from this point, this is our 0.8 from that point. Then again our 0.8 again from this other point. 0.8 again from that point. Again 0.8 from this point. Again 0.8 again from this other point. Again our 0.8 here like that. So that here again this will be our 0.8 like that. After you've obtained those points, again now you stand at this particular point like this. Stand now here at this particular point like this and draw a straight line. After you've been able now to achieve that, now project these other lines and now vertically. No, horizontally like that. Again, project these lines again horizontally like that. Project this other line like this again horizontally. Project this other line horizontally. So from that point, now you've been able now to achieve. Now you want to achieve our name. So this is the name. Your part 1, 2, 3, 4, 5, 6. As you can see now. Then from here now, where 0 and 0 intersect, from this point you mark. Where 1 and 1 intersect, you mark. Where 2 and 2 intersect, you mark. Where 3 and 3 intersect, you mark. Where 4 and 4 intersect, you mark. Where 5 and 5 intersect, you mark. Where 6 and 6 intersect, you mark. Then you now draw your rise of simple harmonic like that. Then after you've been able to achieve that, we are told there is a dual between 150 degrees. When you say 100 divided minus 100, 150 minus 100, it will be 50 degrees. So you convert 50 degrees into centimeters, where we say 360 degrees is equal to 18 centimeters. What about 50? So you say 50 times 18 divided by 360, it will be 2.5 centimeters. So there is a dual of 2.5 centimeters. So you again stand in this particular point and measure 2.5 centimeters at this particular point. Again, you stand here like this. Again, you measure 2.5 centimeters. It will be at this particular point like that. So from this point, again, you draw your line like this. So here, you have been able to achieve the dual. That was the dual. And if that was the dual, now you go back again to your question. You are told that from 150 degrees now to 220 degrees, there is uniform velocity fall. There is a fall. Now there is a return stroke to 20 millimeters. So of 20 to 20 millimeters. So you say 220 minus 150, it will be 70 degrees. So if it is 70 degrees, you take your scale of 360 degrees is equal to 18 centimeters. What about 70? So 70 times 18, what you find, it will be that, then divided by 360, what you find, 3.5 centimeters. So from this point again, you measure your 3.5 centimeters here. From this point again, measure your 3.5 centimeters. It will be at this particular point. After you've measured it again on top here, do the same thing again. After you've measured it, it will be at this particular point. Then after you've measured it, we are told it is a fall of 20 millimeters. If it's a fall, if we had our dual was at this particular point, this is our dual up to this point. So from this point, it is falling 20 downwards. You don't start from down to measure 20. You start from up. It is falling. If you are told it is rising further, then you will start from that point and go further. But it is right. It is falling from this point. So it means from this 60, you go downwards 20. You go downwards 20. So you stand from here again 2 centimeters at this particular point. Again, you stand from this particular point again like this and draw your 20. So this is where it is falling. It is falling at this distance of 20. This is the distance at which it has fallen, at a distance of 20 like that. So after it has fallen a distance of 20 like that, it is falling with uniform velocity of 20 millimeters. So you divide again this into, you divide this 3.5 into 6 equal parts. Divide it into 6 equal parts. For your told it is falling. So you will say 3.5 divided by 6. What will it be? It will be 0.58 or 0.6. So again on your ruler, you measure 0.5, 0.5, 0.58, 0.58. This will be our 0.58. It will be close to that. Again, you measure 0.5 from this particular juncture. Again, 0.5. Like that, 0.58 again from this particular point, it will be like that, 0.58 again from this particular point, it will be like that, 0.58 will be that particular point, that 1, 2, 3, 4, 5, 6 parts. Then now draw straight lines again going up like this. You draw straight lines again going up. after you've drawn straight lines going like that, now you're told it is falling. If it is falling, you know it will start from this particular point here going down like this. So it has gone down like that. So where they intersect with the lines, you make marks like that. Make marks like that. Make mark. You make a mark and make another mark like that. You see, that is very, very much simple. You can do it. You can name this. This is A, B, C, D, E, F, G, H, I, J, K, L, M, N. So we have all those points. Then go back to your question. You're told that from 220 to 270 degrees again there is a dwell. So 270 minus 220, there is another dwell, which is 50. So if 360 degrees is equal to 18 centimeters, what about 50? So 50 times 18 divided by 360, it will be 2.5 centimeters. So from this particular point here, you measure your 2.5 centimeters. So from here, measure 2.5 centimeters. 2.5 centimeters, it will be at this particular point. Then again, from this particular point, again 2.5 centimeters, it will be from here, 2.5 centimeters. Again, it will be like that. So from this particular point, here is a dwell. This is dwelling. This is the dwell. You can also project these lines downwards, please, because when you're drawing your cam displacement, your cam profile, you will have to measure using your compass, so you can always maybe project them downwards like that. Then from there, this is dwell. So from dwelling, again we are told now there is 270 and 360 degrees. From 270 and 360, so you say 360 minus 270, it will be 90 degrees. So for 90 degrees, there is uniform acceleration rotation fall of 40 millimeters. So from this particular point here, so from this particular juncture here, we are told there is a fall. From here, there is a fall. So you say 90 degrees times 18 divided by 360, our distance will be 4.5 centimeters. So standing from this particular point again here, measure 4.5, and you can see very much correctly our 18 centimeters ends at here. So this is 4.5 centimeters. Again, standing at this particular point and this particular juncture like this, you measure 4.5 centimeters, which will be at this point. Again like that, draw a straight line. So from here, now join your line like that. So there we have it. So much correct. So from this point, it is falling. How much is it falling? It is falling for 40 millimeters. You have measured yet is 40 millimeters. That is a stroke. And the distance we are told is 4.5. And it is falling with uniform acceleration and retardation. The next move, you say 4.5 divided by 6. Again, it will be 0.75. So you have to divide the return stroke again by 0.5. So 0.7. So this will be our 0.7. Again, stand here. 0.75. Again, it will be at this point. 0.75 again, like that. 0.75 again, it will be at this particular point. Again, 0.75, it will be at this point. Then the other one is 0.75. Then from this particular point, again draw a straight line like this. Draw a straight line like this. You can see it is very simple. You just have to have the knowledge of the rest of all these things. So it is, you name your parts. So here, this was a fall. So we also name it. We name this. So here, maybe we can also just name it. You can see this is 0 prime, 1 prime, 2 prime, 3 prime, 4 prime, and 5 prime, and then this will be 6 prime. So it is falling. I told you, you measure one. You count 1, 2, 3. Put your finger like that. And you say 1, 2, 3. Put your finger again like that. So which is the line which is left? Number 3 is the line that is left. this number 3 line here. This number 3 line here now is which now we measure. After you measure it, it is 4 centimeters. So 4 centimeters again divided by 6. Divide 4 divided by 6, it will be 0.6. So 0.6 6 times, 0.6 6 times. So this will be 0.6 like that. Again, you measure it, 0.6 will be like that. Again, 0.6 will be like this. Again, from this corner, again, you measure 0.6 like that. Again, from this particular point, again, you measure 0.6 will be like that. Then the rest will be also 0.6. So, from that point, we can name this as A, B, C, D, E. So, this was our N, M. Let us say this is point M. So from this point and M, you draw lines that are touching the line E like this. Here, you draw like that. Then stand at this particular point and juncture again. From this point again, you draw an arc like that. Then from this other point, then from this point again project again, project another line. Remember, it is falling, so I told you when you're falling you begin from this point going down. Please watch the other videos, you will see how I have explained. So from that point, so you start now where this 0 and 0 are intersecting. From this point you mark where line ME is intersecting with 1 prime. Here you make a mark. Where line MD is intersecting with line 2 prime, again at this particular point make a mark. Where MC is intersecting with 3 prime, which is at this point, again make a mark. Where line, let us call this Z, where line ZB is intersecting with 4 prime, the next again make a mark. Where line ZA is intersecting with 5 prime, make a mark. Where line Z is intersecting at this particular point, make a mark. Then draw the parabolic curve like that. So here we have been able to achieve 3. 1, the first part, it is simple harmonic. This is the rise like this. From here to here, this should be the rise. From here to here, this is the rise. And a simple harmonic. What was our rise? Our rise was 100 degrees. Then here we were able to establish a dwell. This is the dwell. And how much is the dwell? The dwell was 50 degrees. Then there is another fall from this point to this point under uniform velocity. Uniform velocity, you can see very well. How much was the degrees under uniform velocity? It was, from uniform velocity, it was 70 degrees. Then there was another dwell, this dwell of 50 degrees. From here to here, this was 20 degrees. Like that. So, how much was this? This was 50 degrees. Then from here to here, we are able to establish now another fall, a complete fall now of the cam under uniform acceleration and retardation for 90 degrees. Yeah, it will be for 90 degrees. So this is a stroke of 2. This will be the stroke of 2 from here to here. This is a stroke of 20 millimeters. This is a stroke of 40 millimeters, as you can see. Stroke of 40 millimeters. These questions are easy if we work together, but if you're alone, it is difficult. It will be difficult. Then here there is a stroke. From here, now there is another stroke. So you can see the stroke was varying. So that's where students get confused. They don't know what to do, but it is as simple as this. That is the cam displacement diagram. And you cannot do anything without the cam displacement diagram. Please subscribe to the next video.